Let's explore the world of radicals and learn how to work with them effectively. Radicals, also known as roots, are mathematical expressions that help us find the inverse of exponents. First, let's understand what a radical actually represents. A radical is the opposite operation of raising to a power. It helps us find what number was raised to get a result. The n-th root of x can be written as x to the power of 1 over n. For example, the square root of 16 asks, what number times itself equals 16? The answer is 4. There are different types of radicals depending on the index. The square root has an index of 2, though we usually don't write it. The cube root has an index of 3, asking what number cubed gives x. In general, the n-th root has index n. Here are examples of different types of radicals. Square root of 9 equals 3, cube root of 8 equals 2, and fourth root of 16 equals 2. Now let's learn how to simplify radicals to their simplest form. To simplify a radical, we factor the number under it into perfect squares, or perfect powers. For example, to simplify the square root of 50, we write it as the square root of 25 times 2. We can split this into the square root of 25 times the square root of 2. Since the square root of 25 is 5, our simplified answer is 5 times the square root of 2. Here's another example. The square root of 72 becomes the square root of 36 times 2, which simplifies to 6 times the square root of 2. Let's explore how to add, subtract, multiply, and divide radicals. When adding or subtracting, we can only combine radicals that have the same index and radicand. For example, 3 times the square root of 5 plus 2 times the square root of 5 equals 5 times the square root of 5. But 3 times the square root of 5 plus 2 times the square root of 3 cannot be combined because they have different radicands. When multiplying radicals, we multiply the coefficients together and the radicands together. For example, 2 times the square root of 3 times 5 times the square root of 6 equals 10 times the square root of 18. We can simplify this to 10 times the square root of 9 times 2, which gives us 30 times the square root of 2. When a radical appears in the denominator, we need to rationalize it. To rationalize, we multiply both the numerator and denominator by the radical in the denominator. Let's rationalize 5 over the square root of 3. We multiply both top and bottom by the square root of 3 over the square root of 3. This gives us 5 times the square root of 3, all over 3. Similarly, 1 over the square root of 2 becomes the square root of 2 over 2 after rationalization. Let's solve equations that contain radicals. To solve a radical equation, first isolate the radical, then raise both sides to the power of the index. Let's solve the equation. The square root of x plus 5 equals 7. We square both sides to eliminate the square root. This gives us x plus 5 equals 49. Subtracting 5 from both sides, we get x equals 44. Always check your solution by substituting it back into the original equation to verify it works. Let's review the key concepts about radicals. Radicals represent the inverse operation of raising numbers to powers. We simplify radicals by factoring out perfect squares or perfect powers. When adding or subtracting, we can only combine radicals with the same index and radicand. We rationalize denominators by multiplying to eliminate radicals from the bottom of fractions. Always check solutions to radical equations, because squaring can introduce extraneous solutions.